All right, so now we learned some congruence postulates. What were the two congruence postulates that we learned? What, Friday? Did we learn on Friday? Side, angle, side, angle. Okay, they're postulates. You can't prove them. But what we're going to do now is we're going to do a theorem that kind of uses the postulates that we did before. And I'll just show it to you right now. And it's called, and that's actually a theorem. All right?
Angle side?
Correct. That's the angle side congruence theorem. So what does that mean? That means if you have, I'll tell you what, let's draw a triangle. I'll just show you how it's used. Let's do this, let's do that. Just drawing some random triangle. And I'm going to copy and paste it so I know that they're congruent to each other. So copy, paste, grab it. Got it first time this time. All right. And we'll make it real easy. We'll call it ABC, DEF. All right, so here's the deal. Now, just by looking at these triangles, can you say that they're congruent to each other?
No.
Why? They don't tell you anything, do they? They don't tell you anything. They don't tell you any sides equal, any angles equal. So there's nothing you can say. I mean, they sure look like they're congruent. And I did say I copied and pasted it. All right. So, but just by looking at it, if I didn't tell you I copied and pasted it, just by looking at it, could you say definitively that they are congruent to each other? No. But what if they gave you this? What if they gave you that angle? Oops, I thought I was doing this in another color. Let's try it now. There we go. All right, so let's say that they told you that angle A was equal to angle D, all right? And they told you that angle B, make it look curvy, there we go, was equal to angle E. And they told you, now, Friday, we talked about the side in between, the included side, correct? But this time, it's a non-included side. So it's two angles and a non-included side. So you could have said that BC and EF are equal, or AC and DF are equal. Let's just do the AC one. AC and DF are equal to each other, okay? Now, Friday, you would have looked at this, and you would have said, no, they're not congruent because that's not angle, side, angle, right? Because the side is not included, correct? But let's take a look at it. Remember, this is a theorem. So a theorem can be what? Proven true, all right? And we're going to do like a little just think through kind of proof. We're not going to write anything down, but check this out. What if you have two angles of one triangle equaling two angles of another triangle, all right? So when you add these two up, they're going to add up to the same thing that these two add up. What is that going to tell you about that third angle? That they have to be the same, right? Because you're doing what? You're taking them away from 180, exactly, right? These two add up to be a number, right? I don't know, let's say 130. Okay, and these two add up to be 130. Then what's this angle have to be? It's got to be 50, and if these two add up to 130, then that has to be 50. Would you agree? So this means if these two angles are equal to each other, then guess what? Angle C must be equal to what? Angle F. Okay, now take a look at it. So now we could go back to our postulate, couldn't we? So give me another reason why these triangles could be congruent to each other. Angle, side, angle. You see that? Right? So, but instead of having to go through all that work to show that this third angle is equal to each other, we could have just stopped and say, okay, we know that the third angle is going to equal. So if I have any two angles of one triangle equaling two angles of another triangle, and the non-included side are also equal, that automatically means that the triangles are going to be congruent, all right? And that's why it's a theorem, because we already stated that angle, side, angle was a thing, right? But now we said, okay, angle, angle, side, but that means that this angle and this angle are going to equal each other, which means I could always go back to angle, side, angle again. So we kind of use angle, side, angle, didn't we? But we don't have to go through that mess with that third angle. If we just have two angles and a non-included side, we can just say that they are congruent to each other. Does that make sense? You understand why it's a theorem and not a postulate now? Because it really deals, it goes back to angle, side, angle, doesn't it? All right? Enough of that. I think that's the only one of those congruence theorems that we're going to learn today. The next lesson, we're going to learn some more, but today I think that's the only one right there. But we are going to learn a couple other things. Let's talk about an isosceles triangle. Do you remember what an isosceles triangle is? What's that mean, isosceles triangle? Yeah, at least. Yeah, two or more. You could say two or you could say at least two of the sides. But most of the time when we talk about isosceles in geometry, we're not talking about the more than two sides, are we? Most of the time we just talk about the two sides, okay? So here is what the theorem says. It says if two sides of a triangle are congruent. So which ones do you think are congruent?
The ones going up and down.
Yeah, these ones right there. Good. The ones going up and down. All right. So if two sides of a triangle are congruent, it says the angles that are opposite those sides, okay, are also going to be congruent to each other. So this is a big deal. This is called the isosceles. Let's write isosceles down. Do you remember how to spell isosceles? ISOS and then CELES. Isosceles triangle theorem. I'll just shorten theorem. Is that all right? So it says, if two sides of a triangle are congruent to each other, then the angles that are opposite those two sides are also congruent to each other. All right? So if I said, call it ABC. So if side AB and side AC are equal to each other, what can you now say because of this theorem? You could say that, what else? Did you guys hear what the theorem said? I didn't write it down, but I said it a couple times. I said, if two sides of a triangle are equal, means it's isosceles, right? Then the angles that are opposite those two sides are also equal to each other. So tell me what are equal to each other. Angle B and angle C, all right? Don't just say B and C. Say what? Angle B and angle C. So if this was true, if this was equal to this, then what? Angle B and angle C are equal to each other. All right? Every single time. They give you a little proof for it, and just due to time, I'm not going to go through that proof. It's not a hard one to do, but we have it. So the isosceles triangle theorem says that. Now, we have a thing called the converse. What does that mean, to take the converse of it? The converse, of the isosceles, I'm going to shorten isosceles triangle theorem. What did the actual isosceles triangle theorem say? What was the if part? The if part was what? If the two sides were equal to each other. So what do you think the converse of it's going to be? We switch the if and the then. So this one's going to be if the what? If the angles. So now, let's do this in a different color. So this one says, if the angles are equal to each other, what? Then the two sides are going to be equal to each other. You see the difference? It's not really saying the same thing, but it kind of is, right? The first one says if the two sides are equal, then, so let's do it like this. The first one, we'll keep that in white, which is our regular theorem. So if AB is congruent to AC, then, let's scooch this over a little bit so I'm not running out of room. Okay, then what's true? If AB is equal to AC, then angle B equals what? Angle C. That's what the isosceles triangle theorem says. Then the converse, you switch the if and the then. So what's that? If what? Angle B is equal to angle C, then what? Yep, side AB, or line segment AB, is congruent to what? Line segment AC or side AC. Okay? That's not too hard, is it? All right. Everybody good? All right. See what else we got. And then I think that's it. Yep. We got one more thing, and it's pretty easy. And it kind of flows from this isosceles triangle theorem thing. So oops. Yeah, let's draw another triangle. Oops. There we go. That's what I want.
Equilateral?
No, yes. It is. Well, technically an equilateral triangle is also what? Well, it is. Whoops. What did I do there? Oh, I didn't copy this yet. Copy, paste. There we go. Well, actually, I don't need two of them. Forget that. I only need the one. Okay. So check this out. If it's equilateral, that's equilateral right there, okay? Now, up to this point, did we know that anything about the angles? Not yet, but now we will, okay? And if we thought about it, well, if we knew that last theorem, that isosceles triangle theorem thing, then we should be able to figure this out. So check this out. So if these two, let's just write letters down. Use A, B, and C. Again, I'm just kind of lazy. What if A, B, and AC were equal to each other? Then what would be true about B and C? They're equal to each other. Now look, okay, it's not just A and B, or A, B, and AC that are equal to each other. AC and BC are also equal to each other. Would you agree? So what must be true? If AC and BC are equal to each other, which they are because it's equilateral, then what? Then B and what? A are also equal to each other. Now, Matu, what is it? Now, yeah, and they are. They're all equal to each other. So if your triangle is equilateral, I'm just shortening this. If you have an equilateral triangle, then it's also what? Equiangular. Then you have an equiangular triangle. Just write it like that. Nice little shortcut. Everybody good with that? So if it's equilateral, automatically it's equiangular. So if you just know that all three sides are equal of a triangle, then you also know, because of that all the angles are equal. And if all the angles are equal in a triangle, they're all how many degrees? 60 degrees. So we're learning a lot of different stuff now about triangles, about the angles inside them and all that good stuff. Everybody good? Okay. That's it. I told you it wasn't going to be too long. So what is it? 1 to 12, 18, and 19. So it's 1 to 12, 18, and 19. Section 4-4, pages, what is it? 172, 173. 172, 173. It's right on that lesson plan thing that I gave you today. Any questions on that? Pretty easy stuff, isn't it? Yeah, but you got to keep it all straight, all right? All this is going to come back to you later on. Even in other chapters, we're going to refer back to this kind of stuff, okay? You understand me? So it's not just for this chapter and then we forget about it, all right? There will be times where we're going to come back to a lot of stuff that we're talking about today. So make sure you get it straight today. All right, that's enough for today.